Hello, hello. So we're going to get the derivative of this function. So this function is actually rational function because imagine we have a fraction, all right, and then we have a number on the numerator and we have a number on the denominator. So what if instead of numbers we use polynomials instead? So we have a polynomial on the numerator, which is x plus 3, and we have a numerator on the denominator, which is 2x minus 1. So what would be the methods to be used in getting the derivative of this? Okay. So there are two methods. First is by quotient rule and second is by product rule. Okay. So let's start first with the quotient rule because product rule, I think it's gonna be longer than this one. So in quotient rule, the formula is basically V times du minus u times dv all over b squared, where your u is the numerator and your v is the denominator. Okay? For this one. Alright? So, unlike for the product rule, this one you have to be very strict. Okay? For product rule, it's up to you. Which one would be your u? Which one would be your v? There's no changes at all. However, for this one, you need to be very strict. Alright? Because your u is always on the numerator and your v is always on the denominator. All right. So that's why here, if your u is on the numerator and your v is on the denominator, then you're going to use this formula. But here's the thing though, mathematically speaking, is it 100% sure that your u is on the numerator and your v is your denominator? No, not really. Okay, not really. Let me give you an example. What if, let's just say, this one, okay, the numerator, okay, is your v, and your denominator is your u. Okay, focus at this one, focus at this one. What if your v is on the numerator and your u is on the denominator? So this is the result. Okay, the result would be what? U times dv. Whoa. It's not supposed to be plus. It's supposed to be minus. U times dv minus v times du all over u squared. Okay, you see the difference here? Yes, just like what I told you, it's not necessarily. So it's up to you if you want to put your u as your numerator or denominator, then your v as your numerator, denominator. It's up to you. However, look at this as we observe. Look at this one, okay? Closely. Compare the the general formula that we're going to use in the quotient rule and this one. Okay, the result would be different, right? It would be much more confusing. Okay, so if I were you, okay, pick your preferences. Which one would be your u? Which one would be your v? Okay, so for me, if my u is numerator and v is denominator, I am going to pick this one. Okay, this is mine. All right, because I used to learn calculus by using this formula. Or if you guys want v as your numerator and your u is your denominator, then you can use this formula. Okay, it's up to you. Okay, but again, be very, very careful. Okay, because in terms of sign, in terms of letters, we are not exactly the same. All right, so that's it. But yeah, since I'm the one who is solving the problem, I'm just going to use this formula. All right, I'm not going to use this one. I'm just going to use this. Okay, so yeah, but again, if you're tired of lettering, like, lettering here, lettering there, right now I'm so confused. Not unlike in product rule, it's much simpler. than this one, right? When it comes to lettering. So there is a, I think, simple way to describe it. Okay. Basically, you can use this formula instead. All right. For your convenience. So I'm just gonna write it in different color. All right. So basically, bot. Okay. When we say bot, it means bottom. Okay, bottom. Bot times the derivative of the top minus top times the derivative of the bottom. Okay. All over the square of the bottom. So it's up to you. For me, if I'm going to pick the most convenient formula, I would rather just pick this. Okay. Instead of this one. If you guys are having a hard time in terms of lettering. Okay. So to sum it up, basically this is the what? The formula of Quotient Rule. Bottom, oh sorry. Bottom, and this one is your top. That's it. Okay? Simple. Alright? So, it's up to you. You can use this as what most of the calculus lessons taught you, where your u is the numerator, your v is on the denominator, or you can use this one, which is, I think, in my opinion, simpler. Okay? Because you can exactly tell which one is from the bottom, which one is on the top. Okay? So, it's up to you guys. So for me, I am going to use this one na lang. Okay? I'm just going to use this. Okay? So if you want to use this, you can experiment it on your own. Okay? So enough with the long explanation. Let's go to the point. So your u is your numerator, which is x plus 3. And your v is your denominator, which is 2x minus 1. Now, what we're going to do is we're going to get the derivative for each of the letters. Okay? So, let's get the derivative of your u. So, how can we get the derivative of x plus 3? So, for the x, if you recall, the derivative of x, okay, you can either use power rule of differentiation, okay, wherein if you're going to differentiate a variable that has an exponent, just simply bring down the exponent, copy the variable, and then the exponent you just brought down will be subtracted by 1. Okay? Or you can just simply use this formula, which is the derivative of cx. Okay? So the derivative of cx is just equal to c. So it's up to you which one would you like to prefer, power rule or the derivative of cx. Okay? So as you can see, for me, I'm just going to use this method because this one is far more convenient to get the derivative of x. Okay. So you see, x here has an exponent of 1. And here has also an exponent of 1. Okay. So the derivative of cx raised to 1 is equal to your c. So here, the derivative of x raised to 1 or the derivative of x, the answer is 1. Because the coefficient of x is basically 1. Okay? Sorry if I speak uh I speak too fast. Okay? I use this one, this method here. Okay, this method because this one is far more convenient than using this one. Okay? So this one basically just get the coefficient. So what is the coefficient of x? 1. Finish. All right? Next, what would be the derivative of the constant term? Okay, so the derivative of constant term is always 0. Okay, so the derivative of 3 is simple as 0. Hence, we have du as your 1. Next, let's get the derivative of your v. So what is the derivative of 2x minus 1? The derivative of 2x, okay, I'm going to use this rule instead of power rule. Again, because this one is more convenient. Okay. So as you can see, the derivative of cx is equal to c. So the derivative of 2x is just 2. And now minus 1. So the derivative of negative 1 is just simple as 0. Because negative 1 is a constant term. Okay? Right. So this would be just simple as 2. Okay? So, yeah, I think that's it. I think that's all what I can say. All right. Basically, guys, this one cx is useful when we encounter this term, just like 2x or x. Okay, because this x, I mean these x's, their exponent is equal to 1. All right. Not unlike two others like x squared, x cubed, x to the fourth power. That's already a different scenario. So you're going to use this one. Okay, if the exponent of the variable is not equal to 1. But if your exponent of x is equal to 1, then just use this. Just like this one, x and 2x. So you can just use this one. Okay, so now we're done. So I'm just going to erase this one because I'm going to occupy these spaces to get the derivative of this function. So I'm just going to erase this one. All right, hold on. There we go. Hi. So the formula is once again v times du minus u times dv all over v squared. Okay. So your v here is 2x minus 1. Then your du is obviously 1. Minus your u, this is x plus 3 times your dv, which is 2. All right. So your v squared is basically a square of 2x minus 1. Okay. Good. So now what we're going to do is we're just going to simply distribute. Okay, let's distribute 1 to each of the terms here. So you're going to have 2x minus 1 as a result. Because 1 times 2x, 2x. 1 times negative 1 will give you negative 1. So hence, it's still the same. 2x minus 1. Next here, we're going to distribute 2 to these terms. So 2 times x will give you 2x. 2 times 3 will give you that. There you go. All right. So now what we're going to do is you're going to simply distribute negative sign here to these terms. So as a result, if you're going to distribute negative sign, you will have negative 2x minus 6. There you go. All right. Okay, so now let's take a look. See, now that we already distribute, now what we're going to do is combining similar terms because there are terms here that are similar or have something in common. We have 2x and negative 2x. Both of them are similar because of the what? Of the variable x. Okay? That's what makes them similar. All right? So if you're going to combine 2x and negative 2x, this would be canceled because they have the same number, the same variable, but in terms of sign, they are opposite to each other. So therefore, 2x minus 2x, it will give you just 0. All right. Next, here we have negative 1 and negative 6. So both of these terms are constant terms. So they are similar. So we're going to combine them. So negative 1 minus 6 will give you exactly negative 7. all over 2x minus 1 squared. And this could be your final answer. Okay, you can bring down the exponent here. All right, then that's it. You will have 2x minus 1 squared. So, yeah, this could be your final answer. This is actually simplified. All right, this is actually simplified already. But if you want to expand the squared binomial, it's okay. So this would be negative 7 all over 4x squared minus 4x plus 1. So it's up to you. But if you want a simplified and final answer, pick this one. Okay, pick this one. Okay, so that's it for the quotient rule. But again, guys, I use this method or formula. You can use the one I just wrote earlier, the one like bottom times the derivative of top minus top times the derivative of bottom all over the square of bottom. So you can do that. Okay, it's okay. All right. It's just that I'm used to answer the what do you call it, the function that involves the use of this quotient rule of differentiation. All right. So once again, it's up to you. Next, let's go to product rule. So as you can see, product rule is only used when we have more than one function that are stick together. You know, for example, let's just say sine x, then cosine x. We can use product rule here. Or in terms of polynomial, let's just say x plus 1 times x squared minus 2. We can use product rule here because overall, both of them are stick together, right? So, see, we can do that. Or we can just use also product rule in terms of this. X squared times 2x plus 10. We can also use product rule here, all right? It's still possible, guys. You can. Because again, as long as they're stick together, you see, we can use product rule. Hence, you know, product rule will exist if f of x times g of x exists like this. They're stick together. But here's the thing. How is it possible that I could use product rule here? So let's have a recap. So you see, have you ever heard of reciprocal identity? Okay, reciprocal identity. Okay. So this one is one of the important lessons you should learn in algebra, all right, or in high school mathematics. So let me give an example. 1 over x. And then I want to make x as a whole term. I don't want him to be on denominator. Okay? I want him on the top, basically. So how would you do that? So basically, you can bring it up, x, but the exponent of it is negative. So since x here, the exponent here is positive 1, therefore, if you're going to put up, what will happen is x raised to negative 100 x squared. So I want to put x squared on the top. So this one raised to negative 2. So you see, I put the exponent into negative. All right. So how about 7 over x raised to 5? So I want to put x raised to 5 on the top. So this would be, copy the 7 times x raised to negative 5. Wait, this is not 5. There you go. Yeah, 5. So this would be just 7x raised to negative 5. Oh, see? That's it. All right. Wait, let me fix this because this is not obviously 5. Okay. So now let's relate it into this one in terms of polynomial. So let's just say 3 all over 2x plus 4 raised to 2. So this one, I can simply rewrite this as 3 times 2x plus 4 raised to negative 2. So lastly, if I have 1 over x plus 7, I can rewrite this as x plus 7 raised to negative 1. That's it. All right. So I can do it in this case. Okay. I can do that here. So let's try. Okay. So with the reciprocal identity, I can simply rewrite this as the derivative of x plus 3 times 2x minus 1 raised to negative 1. Oh, that's it. Both of them are now stick together. So we can now use product rule. So this one's gonna be long, so please bear with me. All right. So you can pick which one is your u, which one is your v. Okay, it's up to you. All right. So for me, my u would be x plus 3, and my v would be quantity 2x minus 1 raised to negative 1. So let's get the derivative of your u. Okay. So the derivative of your u, okay, basically you're getting the derivative of x plus 3. So again, if you're going to get the derivative of x, you can either use the power rule, which is basically, wait, hold on, there you go, which is basically bringing down the exponent, copy the variable, and then the exponent above you used to subtract, you used to bring down will be subtracted by 1. Then you can also use this one for your convenience, which is cx. Okay, so the derivative of cx is just simple as t, where the c is a constant or the coefficient of x or the variable, and then x has an exponent of only 1. Okay, only 1. So as you can see, we have x here. So we can just simply use this method. You know, this one. This one is much more simpler than this. So the derivative of x is just simply as 1. That's it. Okay, because the coefficient of x is 1. All right. Then for a constant term, okay, just use the derivative of a constant term, which is always equal to 0. So this would be just 1 plus 0. So this one is equal to 1. Now, how about this one? Okay, since your v is equal to 2x minus 1 raised to negative 1, what are we going to do? Okay, so here we're going to use chain rule, but in a simplest technique, because if I'm going to use the other technique, all right, it will take a lot of time. So I'm just going to use the simplest technique. All you need to do is use your head. That's it. So if you're going to recall in my previous video, the overall process of chain rule is you're going to get the derivative of the outer function, then get the derivative of the inner function. Basically, differentiate the outer part, then differentiate the inner part. Okay? So that's the same thing we're going to do here. So first, okay, wait, hold on. Yeah, dv. Okay. So first, differentiate the outer part. So the outer part here is negative 1, right? The one, negative 1 here, right? So if that's the case, what are we going to do? Since we have the outer part of this function, which is negative 1, what are we going to use? We're going to use what we call as the power rule. So, okay, imagine that this one, the 2x minus 1 is just x. Just imagine that, okay? So, we're going to use power rule. So, bring down the exponent, negative 1. Then copy the inside, 2x minus 1. Then, the exponent above, which is negative 1, the one you used to bring down will be subtracted by 1. That's it. Times, okay, times, all right. You're going to get the derivative of the inner part. So after you get the derivative of the outer part, now get the derivative of the inner part. So what is a derivative of 2x minus 1? So the derivative of 2x, I'm going to use this rule, cx, okay? The derivative of cx is equal to c. Hence, the derivative of 2x will give you 2. Next, the derivative of negative 1 is basically getting the derivative of a constant term. So the derivative of negative 1 will give you positive 0. So let's simplify. So this is negative 2x minus 1 raised to negative times. So I'm going to put 2 on the front. So I will have negative 2 times quantity 2x minus 1 raised to negative. So that's it. Okay. So yeah, basically that's it, guys. All right. So now I'm going to erase this one because I'm going to occupy this space to provide more solution. Okay. So remember the formula of the product rule, which is u times dv plus v times du. All right. So your u here is x plus 3. Then your dv here is times negative 2 times 2x minus 1 raised to negative 2. Okay, that's it. The next plus your v is 2x minus 1 raised to negative 1 times du, which is just 1. So what we're going to do here is just simplify. So first, I'm going to put negative 2 on the front. So this would be just negative 2 times x plus 3, okay, times 2x minus 1 raised to negative 2. Then here, 1 times 2x minus 1 raised to negative 1 will just basically give you 2x raised to negative 1. Okay. So, it's it's now time to think what we're going to do next. So, in this case, you can distribute negative 2x to this one. Okay. But for me, what I'm going to do first, for simplicity, is I'm going to factor this one. Okay. I'm going to factor this expression. The GCF of this one, of this expression, is 2x minus 1 raised to negative 1. Because this term and this term are both divisible by this term. Hence, I can factor it out. So I'm going to have 2x minus 1 raised to negative 1, all right, times negative 2 times x plus 3 times 2x minus 1 raised to negative 1 plus 1. That's it. Okay. So I can just simply rewrite this as 1 over 2x minus 1. Okay. If you recall that this one, x raised to negative 2 is the same as 1 over x squared. So we can put it back. Okay. So this one, since it has an exponent of negative 1, so we're going to put it back. Okay, by the definition of reciprocal identity. So this one would become like this one. Okay, times. So this would be negative 2 times x plus 3. All right, all over 2x minus 1. All right, plus 1. Okay, if you're asking me, how come that 2x minus 1 is on the denominator? Well, if you're going to take it very slow, okay, this is what it looks like. All right, we have negative 2 times x plus 3 times 1 all over 2x minus 1, right? And plus 1. Then, if you're going to multiply these two, this and this, you're going to put this one on the top. So, as a result, you will have 1 all over 2x minus 1 times, hold on, wait, negative 2 times x plus 3 all over 2x minus 1 plus 1. All right, so that's it. So due to lack of space, so I'm going to erase this one. All right, so let me erase this. Wait, hold on. Okay, so I'm just going to put yellow as my border. Yeah. Okay. So now what we're going to do is I'm going to make this one as a whole fraction. Okay. So by doing so, I'm going to multiply, let me use different color. 2x minus 1 by 1, I'm going to multiply them. Then what would be the product of these two, 2x minus 1 times 1? I'm going to add it here. All right. Again, I'm going to multiply the denominator and 1. Okay. Then what would be the product of them both will be the one that I'm going to add to the numerator. So 2x minus 1 times 1 is 2x minus 1 plus negative 2 times quantity x plus 3. So the result would be negative 2x plus 3 plus 2x minus 1. That's it. And the numerator will just be 2x minus 1. Okay, that's it. Okay, so there we go. Okay, so what I'm going to do is I'm going to, oh wait, I forgot, wait, I'm sorry, wait. Forgive me, wait. I forgot to include this one. Wait. All right, so this would be 1 all over 2x minus 1 times, yep, this would be negative 2x plus 3 plus 2x minus 1 all over 2x minus 1. That's it, finally. Okay, so now what I'm going to do here is I'm just going to distribute negative 2 to this binomial. So I will have 1 all over 2x minus 1 times negative 2x minus 6 plus 2x minus 1. So now I'm going to combine all similar terms. So we have here 2x and 2x. All right. So negative 2x and 2x are similar, just like what I said earlier before. They're similar due to the variables they have, which is just x. So you see, they have the same number, the same variable, but in terms of signs, they are opposite. So the result would be 0. So negative 2x plus 2x will give you 0. So this would be cancelled out. Next, we have negative 6 minus 1. These two terms are similar because these two are constant terms. Hence, we will have negative 7. So as a result, we have 1 over 2x minus 1 times negative 7 all over 2x minus 1. So we're multiplying two fractions here. So as a result, we're going to have negative 7 all over 2x minus 1 squared. So you see, it's just the same as the answer we we solve on the previous method we used, which is quotient rule of differentiation. So yeah, this is your final answer. Or you can, what do you call this one? What's this? You can simply expand this one. So this would be 4x squared minus 4x plus 1. So yeah, so it's up to you. Okay. So that's it, guys. All right. So it's actually a long process if you're going to product rule. But if you like it, sure, why not? It's not a problem to me. I'm just showing you the possible methods uh, that you can do. All right. Let me just repeat what I just said because I speak too much. Basically, you see, I include the other method, which is product rule, so that I am just listing what are the possible methods you can do, aside from quotient rule. Okay. So yeah, that's it, guys. All right. And